you tell me if you haven't seen integration at all? So if you are in year 12, this lesson, everyone in year 13 should have seen this because it's year 12. If you're in year 12, can you tell me if you haven't covered integration at all? Just say no in the chat. If you have seen it, it's okay, don't say anything. But if you haven't, please tell me no in the chat so I know if there is someone that is starting from scratch. Haven't? That's you haven't covered integration, okay? Okay, I hope it's okay anyway. Yeah, we'll cover that more in extension when we have the lesson. But what you're going to integrate in the first thing you should know is the integration is the opposite to differentiation. So if I derivate a function, so if I have a, oh, sorry, this is super thick. If I differentiate a function, sorry, if I have a function and I differentiate my function with respect to the parameter, I have this the derivative. If I go the other way around, I integrate. Yeah. So if I have the derivative and I integrate, I will have the original function. That's what I'm doing. It's like the opposite of differentiation. What you are going to learn in year 12 is to differentiate, to integrate only polynomials. Yeah, in year 13 you will learn other functions. In year 12, only polynomials, which means only expressions of this type. We will have maybe a coefficient, but you are going to have x to the power of something. When you integrate this function, you do the opposite to differentiate it. You are going to increase the degree by 1. So when you integrate this type of function, you're going to still have the coefficient at the front, you're going to increase the degree by 1, and you're going to divide by the new exponent, yeah? Not the n, but the n plus 1. And every time you integrate, you're going to add a constant of integration. Because when we differentiate something, imagine like x cubed. Yeah, if my function is x cubed and I differentiate, when I differentiate, I have 3x squared. But if my function is x cubed plus 2, when I integrate, when I differentiate, I still have 3x squared. So there are infinite functions that has the same integral. That's why we always have to add this constant, and in some occasions we will be able to find it. Yeah, but that's the idea. So the exponent could be anything. So it could be natural numbers, it could be negative numbers, it could be fractions, and sometimes we will have to prepare the questions slightly to be able to integrate. So very quickly, I would like you all, I think maybe when I was talking, you were already doing it, to integrate this function. Yeah, so please give it a go. We are going to integrate 6x plus 2x to the power of minus 3 minus 3x to the power of a half dx. Yeah. My recommendation is when you have terms, you are going to integrate each term at a time, is that you keep the coefficient. And then when you have integrated and write, then whatever you are dividing by, then you simplify your coefficients. Yeah, it's less likely to make mistakes that way. So I would keep the 6, and then I integrate the x. So I will have x squared divided by 2. Then you simplify the coefficient. Yeah. The next one, you have plus 2x to the power of 1 more. So minus 3 plus 1 is minus 2, and you divide by the new exponent, minus 2. The next one will be minus 3, and then you increase this one by 1. So 1 half plus 1 is 3 halves, and then you divide by 3 halves. And then you rearrange your coefficients. Yeah? Don't forget the constant of integration. Always, yeah, we tend to forget that. And then I find the coefficients. So I can use the calculator or not, depending on the numbers, and just write the coefficients nicely. Yeah, so I have x squared, 3x squared minus 1x to the power of minus 2. And then I have this 3 with this 3 can go, and the 2 go to the numerator. So I have minus 2x to the power of 3 halves plus c. The questions usually are going to tell you integrate this function and write the answer in the simplest form or something like that, which only means to write your coefficients this way instead of leaving them this way. If you write, for example, the x to the power of minus 2, or you put it back in the denominator, it's up to you. Both things are going to give you the max. Yeah, it doesn't matter if you write a square root as a power of a half or the square root, or you write x to the power of -3 or 1 over x to the power of 3. Yeah, it doesn't matter. It's clear how we integrate it? Mainly for those who haven't seen it, like Dash, you haven't seen it. So the thing is that the questions are not going to be that simple. Usually you are going to have to prepare a bit your questions. Yeah, so you really want to have x to the power of something. So sometimes the questions will need a bit of preparation. So if you have a root, for example, remember you can write x to the power of a half, or when you have an x in the denominator, you can write it in the numerator as negative. So you will have to prepare a bit the question. Or if you have a bracket, sometimes you have to expand the bracket. Yeah. The thing is that you prepare your questions so you have x to the power of n. The same that you do when you differentiate, really. Yeah. So let's do the first one. So I have to integrate that function. So I'm going to prepare it. So please do it with me. If you know what you're doing, do it with me. And if not, you just listen for the first one. So the 3 in the denominator goes negative in the numerator, and then I have 3 and x to the power of a half, yeah, dx. Again, we do the same than before. So we keep the coefficient, x goes to 1 more, so -3 plus 1 is -2, divided by the new one, and then I have -3, and x goes to 1 more. Sorry, more people joining. So 1/2 plus 1 is 3/2, and then I divide by the 3/2. Don't forget the c, and then I simplify my coefficients. Yeah? So minus x to the power of -2, minus this cancel, and the 2 goes to the numerator, x to the power of 3/2 plus c. So it's quite simple. So you just are going to integrate all the time x to the power of n, and if you don't have x to the power of n, there are ways of writing it in terms of x to the power of n. Yeah. Can you do this one, for example? I think if we have time, maybe we can come back and do the ones that we leave, but I will like you to try this one. So please think how you have to prepare the question so you have x to the power of something, yeah? So hi to everyone that I didn't say hello. You were joining slowly. So please try to do that one. So I'm going to prepare it. I'm going to have 4x squared. And then this one, I have x to the power of 1/2 divided by x squared. Yeah, I can divide these two terms by x squared. If I have x to the power of a half in the numerator and x squared in the denominator, I just subtract the indices. I have 1/2 minus 2. 1/2 minus 2 is what? Minus 5/2. So I have x to the power of minus 5/2. And then this one is 5x to the power of -2. Yeah, so plus 5x to the power of -2 dx. And now I can integrate easily. Yeah, coefficient x to the power of 1 more divided by the new exponent. The next one, x to the power of 1 more, so -3/2 divided by new exponent. Next one, the 5, x to the power of 1 more, so -1 divided by a new exponent, and plus c. Yeah, so we are doing the same all over and over. And now I simplify the coefficients. So 4/3, we cannot do anything about it, so we just leave it. Then this becomes negative 2/3 x to the power of -3/2, and the next one negative, but again we cannot simplify much more. Yeah. Is it okay? Is it clear? Everyone? Do you have any questions? So all the year 12 questions are going to be always integrating polynomials, the same that you just differentiate polynomials. The questions are going to be complicated when you have to apply the integration. Yeah, the same that when you apply the differentiation to find tangents or gradients or points, the stationary points. So the questions are more complicated for the applications more than the actual integration or differentiation. Yeah. You have something called definite integrals. So the integrals that we have seen so far, where we don't have these two numbers, are called indefinite integrals. If we have these numbers, are called definite integrals. Instead of getting an expression, like before, 2x to the power of whatever, we are going to get a number. That's why they are called definite. So what we are going to do is we are going to integrate as normal, and then we are going to substitute these values. So if I have the integral between a and b of a function, I'm going to integrate the function, and then I'm going to substitute the b. So imagine this answer is f of x. Yeah, I'm going to do f of b minus f of a. I'm going to substitute this b in this function, and then minus this number in the function, and then I get the number. Yeah, I'm going to do with this example, don't worry. How would I integrate this function? What do you think? How can I prepare it? Who can tell me? Before I integrate it, because now I don't know how to integrate that. What can I do? Who can tell me? You can raise your hand, unmute, whatever you want. How would you prepare that function?
You don't need to integrate and then find the limit.
Yeah, but how can I integrate it? What would you do to integrate that one? Fraser says expand. Yeah, I'm going to expand the bracket. It's just a square, two terms. It's very quick to expand. So I'm going to expand. And once I have expanded, then I can integrate and substitute the limits as Hamza said. Yeah, so let's go into expand first. So I'm going to do, remember when I have a plus b squared, I can do a squared plus 2ab plus b squared, or I can expand the brackets and then simplify, which is slightly longer. But if you remember this, it's quite handy, it's very quick. So this one is squared is x to the power of 1/3 squared is x to the power of 2/3. Yeah? Then if I have a minus here, this is going to be minus. Yeah, minus, minus. So I have a minus, is going to be minus 2 times x to the power of 1/3 times by 1, and then plus the last one squared. I'm just expanding the bracket in a faster way than multiplying all the terms and simplifying after. Yeah. And now we can integrate. So let me integrate. Does anyone want to tell me? Who wants to tell me? Who wants to help me with this question? Someone? Rex, can you help me with the question? What am I going to write?
So would you add 1 to the power for the first one and then divide by the new power? So 3 over 5 x to the power of 5 over 3?
Exactly. I'm going to write at the moment this, and then we will swap the coefficients. What about the next one?
And then negative 3 over 2 x to the power of 4 over 3.
4 over 3 divided by 4 over 3. And then the next one?
Plus x.
X. Excellent. That's it. I don't have to write the constant of integration now because I'm going to substitute two numbers, and the constant of integration will be plus c and then plus minus c, so it's gone. When I have limits of integration, I don't need to write the constant. If you write it, it's not wrong. So now, as Rex was already giving me the coefficients in a nicer way, so this 3 goes to the numerator. Instead of copying it again, I'm just going to write it in the numerator. And this one, I can simplify. So instead of 2 and 4, I'm going to have a 2 here, and the 3 goes up. So I have 3 halves. Yeah, 3 halves. 3 halves. If you get confused doing the reciprocals and dividing by a fraction, just do it with the calculator, mainly in the exam, because when we are nervous, we do the most silly things. So if you are not confident, just do it with the calculator, it doesn't matter. So now I'm going to substitute the 1 everywhere. So I'm going to have 3/5 times by 1 minus 3 halves times by 1 plus 1. Yeah, I just substitute the 1. So this is like my function when I substitute the 1 and the 0. And now we are going to substitute the 0. When I have the 0, I have 0, 0, 0. Yeah, when I say substitute, it's just substitute the x by that. So I would write still 0, so they see that you haven't forgotten. And this is 3/5 minus 3/2 plus 1. I don't know what that is. This is 1/10. And this is the answer for this integral. So when we have limits, we will be able to find a value unless one of the numbers is a constant, and sometimes we need to leave it in terms of a constant. Yeah, but that's what we are doing. They are going to ask you solve, find, and sometimes they will say evaluate. It means the same. Evaluate just means find the value. Is it clear what we do? Remember, top number minus bottom number. Don't do the other way around. Yeah, we substitute first the top and then minus the bottom. And if you have, here we have 0, but if you have numbers, I would write a bracket because it's very easy to remember to change the sign of some, but not all of them. Yeah, so be careful with that. Is clear? Easy? Okay, let's do one question. The gradient of a curve is given by this expression, and the curve passes through the point 620. We have to find the equation of the curve. We say derivative is the opposite to integral. So if we have the derivative function, which is the gradient, sometimes the question won't say this. They don't say dy by dx, but you know that the gradient is the derivative. Yeah, so please remember that. If we know the gradient, we can find the curve integrating. So let's go into integrate. The curve, my y, is going to be the integral between, we don't have limits, x squared minus 3x. So super quickly, everyone doing that integral, please, because it's very simple. So we have x cubed, so 1 more, divided by 3, minus 3, 1 more, divided by 2, plus the constant of integration. Yeah? Why do you think they give me this point? Can someone tell me?
You can substitute it in.
And what do I get if I substitute in?
You get
What does that advantage? The constant of integration, yeah? Exactly. So I can substitute the point because I say there are infinite curves that has the same derivative, only one that pass one particular point. Yeah, so this constant is just giving me a family of curves that are like parallel. When they give me 1 point, they are helping me to find the specific one that passed this point. Yeah, so I'm going to substitute the point and find C. I substitute the y by 20 and the x by 6, and I have 6 cubed divided by 3 minus 3 times 6 squared divided by 2 plus c, and from here I find the constant of integration, and I am able to find the actual curve. Yeah. Two, I get 2. You get 2 as well? Yeah, okay, thank you. So that means that my curve is going to be x cubed divided by 3 minus 3x squared divided by 2 plus 2. This is what they are asking. So please, when they ask you the equation of the curve, give the equation of the curve. Yeah, don't stop here, find the constant, and don't write it. This is the equation of the curve. Then, hence, so we are going to use that information. We have to find the integral of this function between 1 and p in terms of p. So we are going to leave our answer in terms of p, and that's fine because that's what they're asking us. So for b, I'm going to integrate my function minus 3x squared divided by 2 plus 2 dx, and my limits are 1 and p. So as I did before, first I integrate my function and then I substitute the limits. Yeah? So I am integrating y, and y is this function that I just found. Is it clear? So let's go into integrate. I have these 3 here, but I'm still increasing these to 4 and divide by 4. So this 3 goes multiplied by 4. Yeah, we can do into steps. So I have the 1/3. Sorry, this goes up to 4, and the new exponent is 4. Yeah. So this 3, don't get confused, is this 3, and this 4 is this 4. So I have two numbers that multiply. Then minus 3x cubed divided by 2 and by 3. And then I have plus 2x. And this goes between 1 and p. I'm going to write my coefficients a bit better. So I have x to the power of 4 divided by 12 minus, I can cancel these 2. So I have x cubed divided by 2 plus 2x. And once I have integrated, I can substitute. Yeah. The p first. So I have p to the power of 4 divided by 12 minus p cubed divided by 2 plus 2p. That's when I substitute the p, and then minus, I substitute the 1. So I have 1 over 12 minus 1 over 2 plus 2. I cannot do anything with the p's, so I'm going to leave p to the power of 4 divided by 12 minus p cubed divided by 2 plus 2p, but I can put the numbers together, yeah? Minus 19 over 12, do you get that? Yes, did you get that? Okay, excellent. So this is an example of usually the questions in year 13, they might ask you just integrate a function, and maybe the function is difficult. In year 12 is less likely. So the questions are going to be worded in this way. They are going to be a bit more, you're going to integrate something, but to find an area or to find something else, yeah? And this is what you're going to do in many of the exam questions. I think even in year 13, you're going to find areas. We use integration to find areas all the time. So the area under the curve, so like trap between the curve and the x-axis between two values of x is going to be the integral of this function, and the limits are going to be these 2 points, yeah? This is the area under the graph. So we can find the area under the graph integrating our curve between these two values. And so let me show you with one example because it's easier than it looks like. So we have a sketch of the curve with equation, this one here, so 3x plus 6 over x squared minus 5, when x is positive, and region R is bounded by the curve, the x-axis, and the lines x equals 1 and x equals 3, and we have to find the area, yeah? So the only thing we are going to do is to integrate between 1 and 3, yeah, between 1 and 3, the curve. We are going to get a value, and that's our area. So it's very simple. So 3x plus 6 over x squared minus 5 dx. Okay, who can help me to integrate that? Year 12, please. Who can help me? Sophie, could you help me?
Maybe.
I hope so. Come on. 3.
3, would it be x to the power 2?
Divided by?
Divided by, sorry, 1 second. Divided by 2.
2, the new exponent. Excellent. Then plus 6. I'm going to write this as x to the power of minus 2. Yeah, because that's the way of knowing how to integrate. Can you integrate that x to the power of minus 2?
Yes. So 6. Oh, what do you mean by that? Sorry, this is a new topic to me.
Okay, we increase the power by 1. So minus 2 plus 1
okay. Yes.
is minus 1, and then divided by?
Minus 1.
Minus 1, excellent. And then when I have a number alone, I just put the exactly. Yeah.
Okay.
So Jardine, amazing for being new for you. Excellent, Sophie, thank you. So now we are going to substitute the 3 minus substitute the 1. Yeah, so let's go. We have 3 times 3 squared divided by 2 minus 6 times 3 to the power of minus 1 minus 5 times 3. All minus, I substitute the 1, yeah? So this is f of 3, and now I'm doing f of 1. When I substitute the 1, I have 3 halves minus 6 minus 5. Yeah? I'm just very careful, calculator, and we find it. One note here. You have a function in your calculators, in the ones that you are allowed in A levels, that have definite integrals. You have to be careful using that. First, you have to show you're working out. So I would say this step of substituting things is important. And this step of integrating the function before substituting is important. If you miss these steps and you just give the answer, you are not going to get the marks. And then there is a risk on doing that. And I'm going to show you when we in a minute. Yeah. So be careful with that. Maybe you can use it to check, but if you are sure what you are doing, if not, it's a bit tricky. So I get minus 7 halves. Minus 7 halves? Do you get minus 7 halves there? Minus 19 halves. So I have 19 halves minus 7 halves, 12 halves, which is 6. Did you get that? Yeah. Okay. You're always faster than me. Okay, so this is the area, and that's how we find it. We are going to integrate our function between 2 values of x. So we need limits of integration, and we need to know. So our area is going to be limited between 2 values of x. Yeah. Sometimes your values of x are, for example, imagine you are trying to find the area enclosed by a quadratic. This area here, you will have to find the roots and then integrate between those roots. Yeah, but that's what you are doing. To find areas, you are integrating your function always in between 2 numerical values. Is clear, even for those who haven't done this before? Now, what happens is when we integrate a function that is over the x-axis, so if you integrate this part of the function between this value and this value, you get a positive value. If you integrate a curve that is under the x-axis, your answer is going to be negative. So when we are trying to find integrals, it's okay. Our answer could be negative or positive. It doesn't matter. But when we are trying to find areas, that's a problem. Because if I integrate between, let's say, A and B, and I get this is positive, and then get this negative, my answer of my integral, so if I integrate between A and B that function, it could be 0 if they are equal, yeah? Or if not, is 0. If it's not 0, it could be that is just this one is negative and is subtracting. So it's not going to be the area, it's going to be less than the area. You see what I mean? So be careful, because if it's the integral, it's okay to be 0, negative, positive, it doesn't matter. But if you are finding areas, you have to be careful. Do you know what is the way of going around that? Do you have any thoughts? How can I do to find the actual area?
You do 2 separate integrations. So you do A to 0 and then 0 to B.
Exactly. And one is going to be positive and the other is going to be negative. And then what I do with them?
Do you take the negative one to be positive and then add them together?
Exactly. So that's how I do it. I'm going to find both separate and then I'm going to add them both positive. Yeah. And that's what I have to do. So when they ask you to find an area, you have to be careful. In many occasions, they are going or to ask you to do a sketch first, or they are going to give you the sketch. So in that case, you will be able to see if your graph is under the whole the x-axis or partly above, partly below, and then you know that you have to split your integrations. Yeah? If they don't, please do a sketch, because that happens, I would say, mainly in the mechanics questions. So in mechanics, probably in year 12 you haven't covered this because it's one of the last topics. When you do variable acceleration, you have graphs. So instead of having constant acceleration, you have graphs, and you are integrating graphs to find maybe distances, and that happens. And if you don't do the sketch, maybe you don't realize that one part of your graph is under the x-axis, and that's subtracting, and you have to split it. Yeah. In the pure questions, I would say in all of them, they are going to ask you to do a sketch first, or they are going to give you a sketch. Yeah. You have some questions to practice. I will send later, and you will see that you have the sketch. Yeah. Super important. If not, you are not going to get the right area. And your answer for the area never can be negative. So if they ask you to integrate and to find the area, let's say, between these 2 points, when you integrate this value, you're going to get minus something. That's the integral. The area, imagine you get minus 12. The area, when you answer the actual question, you have to say that the area is 12, not minus 12. Yeah, don't ever give an area negative because you will lose a mark. The area is not minus 12, it's 12. So the integral is like a tool to help you to find the area. It's not always the area. Yeah. So what happens with the calculator that I said before, be careful, is that if you have a situation like this one, so imagine you are integrating this to find the area. If you integrate between this value and this value, this is going to subtract from this bit. And the answer that the calculator gives you is smaller than the area. Yeah. And as an integral, it's okay. But as an area, it's not okay. It's less than it should be. Yeah. So the calculator doesn't find the area, find the integral. Yeah. Finds the integral. Any questions? Is this confusing for year 12 that haven't seen this? No? It's okay? Okay. So then I let you think a tiny bit of this question. I'm not going to do anything. I just want you to try. So you see, they give you the sketch. This is a cubic. And they say the diagram shows the curve with this equation. And we have to find the coordinates of the points where the curve crosses the x-axis. So we are finding the roots. It's not difficult because we have x everywhere. So this is very easy to factorize to find the roots. So please go ahead, factorize it. And when you have the roots, I would like you to type them in the chat, please. So when you have the roots, you just type them in the chat. So I have some roots on the reader. Please see if you agree with 0, 1 and 5, 0, 2 and 3. Okay. So we factorize the x outside. I think you are all getting them right. I saw something different at the beginning, but we have x squared minus 5x plus 6. And then we are going to factorize this quadratic. You know how to factorize quadratics. So this is x minus 2, no, x plus 2, x minus 3, no? No, x minus 2, x minus 3, sorry. X minus 2, x minus 3. So my roots are 0, 2, and 3. This one will be 2, and this one will be 3. That's our situation. Then they say, show that the total area of the shaded regions enclosed by the curve and the x-axis is 3 and 1/12. Yeah. What are we going to do? What we said before. We are going to integrate between 0 and 2, and then we are going to integrate between 2 and 3. We don't necessarily need to integrate twice. What we need to do is to substitute twice. Yeah, don't do the whole integral maybe again, but you can substitute twice. So let's go into integrate that function. I'm going to integrate between 0 and 2. My function is x cubed minus 5x squared plus 6x dx. Who can help me? Dars, you haven't covered this. Are you okay to help me?
Yeah.
Go on. X to the power of
4.
4 divided by,
4.
excellent, minus 5x to the power of
3.
3 divided by
3.
3 plus 6x to the power of,
6x squared
yeah, divided by,
divided by 2.
perfect, that's it, yeah? And I'm going to simplify the 6 and the 2, so I'm going to write 3 instead of 6 and divide by 2, yeah? And now I'm going to substitute this between 0 and 2, and then I'm going to do the same between 2 and 3. But what I'm going to do the next time is to copy this instead of thinking it again, yeah? So I substitute the 2, so I have 2 to the power of 4 divided by 4, minus 5 times 2 cubed divided by 3, plus 3 times 2 squared minus 0. Yeah, so I substitute the 2, and then I substitute the 0. I get minus, no, I cannot get minus. I've done something wrong. I get minus 10 over 3, but it cannot be negative. What did you get? Can someone tell me what did you get?
I got 4.
4? Just 4?
Yeah.
More 4s? Someone else? You want to type in the chat what you get? Okay, let me do it again. 2 to the power of 4. You get 8/3. Lunel is nodding, some more 8/3. 8/3. Okay. So there must be 8/3. I don't know what I've done. 8/3. Now I'm going to do between 2 and 3. So we do the same. We copy the function that we already integrate, and we substitute, and we are going to get a negative value. We already know that because it's below the x-axis. Yeah. And that's okay, because then we are going to change. So now between 2 and 3, we always go from left to right in the x-axis. So sometimes you don't know which one is which one. We always go from left to right. So if we integrate 2 to 3, sometimes you could, to get this one positive, change the limits of integration. But I don't think it's unnecessary. So you are going to get a negative value, and then you add it positive. Yeah. So we substitute the 3 to the power of 4, 4, and so on. Yeah, let's substitute the 3. And then we substitute the 2. I get something horrendous. Did you get this value? No. 'So I get 9/4 for the first one. 9/4. No. Minus 8/3. Minus 5/12. Yeah, this value. Do you get that value? Okay. So the area, that's what they are asking, is going to be the first bit positive 8/3 plus the second bit but positive as well. Yeah, 5/12. So I get 37/12. and that's the area. Yeah, do you get that value? Okay, excellent. So this is how we find the area. Is it clear? So always, please, when they ask you to find areas, not just the integral is okay. Always check what your graph is doing. They are going to give you easy graphs to represent or to know at least what the graph is doing. In this question is a bit scaffolded because the first thing they ask you is to find the coordinates of intersection. If they don't ask you this bit at all, you still have to find them because it's the way of knowing if there are roots and in the graph is above or below the x-axis. Yeah? So you still have to find those roots. Is the question clear for everyone? Okay. The last thing you have in year 12 really is to find areas between curves. So far we have done between the curve and the x-axis. In most of the questions, you will have to find between two curves. Many times are going to be one curve and one straight line. Sometimes could be two curves, yeah? There are like two ways of doing it. So I'm going to start with one that is not two lines, so you see what I mean. Imagine you have to find the area trapped between, I don't know, this graph here, this one here. So quadratic, and let's going to call this gx and this one fx, and we need to find this area here. Yeah, what we are going to do first in any case is going to find these points of intersection because those are going to be our limits of integration. Let's say this is a and this is b. We have two options. We can integrate between a and b fx. So that way we will find all this area up to no between the limits, yeah? And then integrate gx, and then we will find the area under gx, and then subtract, yeah? Or, so we can do the above one, which is fx, find the area, and then subtract the gx. Yeah, or we can subtract them first and then integrate. So we can integrate fx minus gx dx. You are going to get the same answer. And sometimes if you subtract first, as these are polynomials, the question can be simpler. Yeah, so you are going to work usually less if you subtract first than if you find each area at a time. It's okay because you're going to get the same answer. So it's up to you and what you see better. And sometimes when one of them is a straight line, instead of integrating to find the area under the straight line, you just can find the area of the triangle. If you integrate, you're going to get the same area. Yeah. So if you integrate this line, you're going to get the area of the triangle, believe it or not. But you can find the area of the triangle maybe faster than integrating. Yeah. So up to you. You subtract the equations of the lines and then integrate, or you just subtract. So let me show you with this question, we can do both, and then you will remember that forever, I imagine. So this is y equals x, and this one is x 4 minus x, which means we can expand the brackets. If we can do anything interesting with that, is expanding the brackets. Yeah. Option number one, I'm going to integrate my quadratic, and then I'm going to subtract the area of the triangle. So I'm going to do it like in 2 steps. If I integrate my quadratic, I'm going to find this area, always the area under the curve. And then I'm going to subtract this triangle to find the yellow one. Yeah, that's what I'm going to do. The area under the graph is going to be the integral of this function between 0 and the point of intersection. I'm going to stop here. I don't have any reason to find anything further the point of intersection. Point of intersection, can we find it, please? To find points of intersection, simultaneous equations, just that. Yeah, so I'm going to solve simultaneously y equals x, or I'm going to make them equal to each other, however you prefer to think, or x minus x squared. Yeah. So we have x is 4x minus x squared. So x squared minus 3x is equal to 0. Factorize, and my roots are 0 and 3. 0 is this one, so the line and the graph meet here and here. So this point is 3. That's the one I'm looking for, yeah? That's my limit of integration. So I say option 1, let's going to find the area under the quadratic. How do I find the area under the quadratic? Who can tell me?
Just standard integration.
Between what and what?
0 and 3.
And what function I'm going to integrate?
Y equals 4x take x squared.
Exactly. I integrate this between 0 and 3. Very quickly, we have 4x, 1 more divided by the new one, minus x, 1 more divided by the new one. And then I don't need the constant because I have limits. Yeah. And if you want, we can simplify the 4 divided by 2. So I'm going to write, I know if you are doing on paper, you cannot do, I'm going to cheat and just clean it. So 2x squared, and I'm going to substitute the 3. So I have 2 times 3 squared minus 3 cubed divided by 3 minus 0. Yeah, when I substitute the 0, I will have 0. And this is 9, no? It's 18 minus 9, yeah. 9. So this is the area that I color here in pink, but that's not the yellow one that we want. So what are we going to do? We are going to remove this triangle. Can we find the area of this triangle? Yeah, we know the base. The base is 3, and the height, we have to find the y-coordinate of this point. By the y-coordinate of the point of intersection, as it belongs to this line, is going to be equal to the x. So this point here is the 3, 3. Yeah, 3, 3. So this point is 3. So my triangle is 3 times 3 divided by 2. Yeah. So the area of the triangle is 3 times 3 divided by 2, which is 9.5. So the yellow area, I'm going to write the pink area and the yellow area. The yellow area is going to be 9 minus 9/2, yeah, which is 9/2. Is it? Yeah, 9/2. The other option, so this is option number 1, if you want. The other option that should give you the same answer is doing straight away the curve that is over or above. Which one is? The quadratic. So this thing here minus the line that goes under. This, in the case of a straight line, doesn't make much of a difference. In the case of two polynomials, it will. Yeah. So we subtract the curve under, which is the quadratic, the 4x minus x squared, minus the other one, which is y equals x. So minus x. So it's y of one curve minus y of the other curve, if you want. Yeah. So this is the quadratic, this is the line, dx. So we can simplify before integrating, and we are integrating before between 0 and 3, like before. Yeah. So we have 4x minus x is 3x minus x squared. Yeah, I simplify because I can put these two together. And I integrate, I have 3x squared divided by 2 minus x cubed divided by 3 between 0 and 3. And when I substitute, I'm going to get the 9/2 that I got before. Yeah. So I want to show you something else before finishing, so I don't want to dedicate much time to this one. But we have the right answer, no? 3 to the power of 3. 9/2, yeah, just in case. I want to check if we've done correctly. Yeah, you get the same answer. So either way, you can subtract the graphs and integrate, or you can integrate one graph, the other graph, and subtract. And some of the bits that you have to subtract are going to be very simple rectangles, trapeziums, triangles that are very easy to find. So it's a bit up to you. Yeah, and a bit of the question, I would say. One warning. When you have to find areas like this one, when one of your graphs goes under the x-axis, I wouldn't use the subtract first. Yeah, if you do this and you integrate between this value and this value, you are going to have this bit subtracting this bit, and it's not going to work in most of the cases. Yeah. So in this situation is one of those that I will find the other way, finding one area and subtracting another area. Does it make sense? So like the first method that we use. Can you think, even if we don't do it, because maybe we don't have time, how would you find this yellow area? What would you integrate? What would you subtract? Or how would you do this question? How can I find the yellow area? And remember, when I integrate a function, what I have is the area under the graph.
Would you find the roots of the polynomial first?
I will definitely find the roots. So imagine I know them already.
And then do the integration between 0 and a, and then subtract that from the whole integration of the curve.
Between 0 and a is not going to give me the area, because this is going to be negative. And then I subtract that from where?
Is it the whole integral between the 2 points?
Between the 2 points? So between 0 and b, or between a and b?
Between 0 and b.
Between 0 and b, this bit is going to subtract from this bit. You see what I mean?
Yeah.
You're very close. What else can I do? Any other thoughts? I can. Nobody? Really? Come on, don't be shy. Harriet, tell me, what can I do?
I think if you integrate between A and B, you can find that little bit on the end, and then you have to find like the area of the triangle between 0 and B. Yeah, that, and then subtract the area of the integrated bit that you did.
Exactly. There is always more than one way of doing these questions, usually. That's what I would do as well. So if you find this area, because you have the coordinates of the points and it's just a triangle, you can easily find it. And then what you don't want for the yellow bit is this area under the graph. So you integrate between A and B, the polynomial. Yeah, and that will find this pink area. Does it make sense? So only be careful when you have negative parts. You have to be like super careful with what you are doing and how. Let me show you. You have questions to practice. Yeah, you will have a PDF with questions to practice. What would you do in this one? Again, I prefer to show you a few questions just to think how we will find it. Imagine we have found the intersections, because we know how to find the intersections, and we know this point of intersection, this one, wherever we need. How would you find that area? And in this case, I have the two options because nothing is negative. So one would be subtracting this equation minus this one and integrating, let's say this point is A, yeah? So straightforward, this line minus this graph between 0 and A. And I have the equation of the graph, and I am able to find the equation of the line, yeah? They asked me in the first part. What would be another option? Who can tell me? Ryan, what do you think we can do? Imagine I do like in the steps.
Well, did you say when you make them the same or not? Like you make them equal to each other?
Make them equal to each other? What make them equal to each other? What do you mean?
Uh,
Yeah. Imagine I solve these simultaneous equations and I know this value. What I want to find now is the area. I can do subtracting and integrating. What would be another option? What can I integrate and subtract from what to find the shaded area?
if you found the y coordinate of like a,
Mhm.
could you do like the area, like the limits could be like the y-axis instead of the x-axis? I don't know if that works, to be honest.
To integrate and use the y-axis limits? No.
Yeah.
It won't work. What can I find? So always think this is an integration question. So if I integrate my graph, I'm going to find this area. So how can I find the gray area instead of that one? Because I don't want that one.
You can find the area between 0 and a underneath the straight line. And
Exactly.
then the area.
The area limited by the straight line is a trapezium. Yeah, so this area here is a trapezium. I have all the information because I know the y-intercept, I will know the y-coordinates, so I know parallel sides, multiply by the distance, divide by 2, so I can find the area of the trapezium, and then?
You use integration to find the area underneath the curve between 0 and a, and then minus that.
And then minus that, exactly. So this is a bit of practice. If you're not able to see these questions, because I know that sometimes it's a bit tricky to see them, I would recommend you think, if I integrate my curve, what I'm getting, and just shade it and think, oh, this is not what I want, but I can subtract it from somewhere else. Like before, what happens if you integrate the curve between here and here to a mess? You are getting something negative. Between here and here, you are getting this bit. That is precisely what you don't want out of the triangle. So always think, if you integrate, what you are getting, and if that helps you. And if not, just subtract the curve. So if you have the equation of this line, let's say this, I'm just making it up. Y is 2x plus 1. What I can do is integrate between 0 and a, the graph that is above, which is my line, so 2x plus 1, minus the line that is below, which is my quadratic, minus 5x minus 2x squared dx. Yeah, I can do that way because I don't have anything negative, so this will work. If not, what you can do is the trapezium minus the integral. Yeah, I know it's almost the time, but I want to show you one other. Last one. What would you do for this one? I hope now you are starting to see. Think what happens if I integrate. What do I get? Imagine I know the equation of the line, the points, everything. I have all the information because you will have it. How can I find that gray area? I know this point.
Would you find the area of the whole rectangle or the square, whatever it is, and then integrate underneath the curve and then subtract that from the area of the square?
Exactly, that's it. So if I integrate my curve, what I'm getting is under. So I'm going to get this pink thing. But I can find this rectangle or square, wherever it is, because we don't know, and subtract the pink to have the gray. You got it, yeah? That's the idea. If not, again, I can subtract this line, because it's the one above, minus this function, because it's the one below, and integrate. Up to you, because I don't have anything under the x-axis. So that's the idea, and I think that's the bit that is sometimes a bit tricky to see. So these questions are worth practicing because integrating polynomials have no mystery. You have seen how quickly you have seen it, yeah? It's just, sorry, someone else is joining. Is these questions, the ones that can be a bit tricky. So the more you practice, even if you don't complete the numbers because you are in a rush, see the idea of how would you do them. Maybe then the working out is long and unnecessary, but see what would you subtract and how would you find it. Is it clear? Was it helpful? Okay, so year 12 students, this is year 12. You will get the recording later, and and a PDF for questions to practice. If you do the questions, they come with a video, but if you struggle, you tell me. Yeah. And if you want, the other 13 students, I give you a couple of minutes so you can have a drink and then we start. We will finish later. If we start later, we will finish later. But I think as you want to stretch or something. Yeah.
Just to ask, you're doing your 13 content now?
Yes, I do. Yeah. You have Fraser, you have the year 12 content. That's what you no? Okay. Then see you in a minute, everyone. Fraser, on top of you will get the recording later. Yeah.
Thank you.
Bye bye. Bye bye.
Thank you.
Thank you.
Thank you.
Thank you.